everybody. So today's topic is polarization, right? So before polarization phenomena, interference and diffraction phenomena successfully explained that light is having wave nature, but they didn't really reveal the fact that whether light is longitudinal wave or transverse waves. Experiments proved that light exhibits transverse nature, and the phenomena of polarization confirmed that light exhibits transverse nature. Now let us do one small experiment. One is to prove that light exhibits transverse nature. Other is to define what is polarization, right? So now for that, let us take a tourmaline crystal. Okay, here we are taking a tourmaline crystal. Let this be the direction of propagation of light. Propagation of light, right? Now I took a tourmaline crystal, placed in such a way that its plane is at right angles to the direction of propagation of light, right? Now this is ordinary light. We can also call it as unpolarized light. Unpolarized light. Now tourmaline crystal converts this unpolarized light into polarized light. It converts unpolarized light into polarized light, right? Now I am taking another tourmaline crystal and I placed this another tourmaline crystal P2 in such a way that the plane of P2 is parallel to the plane of P1, or we can say that these two planes are at right angles to the direction of propagation of light. Okay, now this polarized light passes through the second tourmaline crystal, and we observe that when the two planes are parallel to each other or at right angles to the direction of propagation, we will find maximum intensity of light. Means this P2 emerges this polarized light and we will find maximum intensity. Now next what we are doing means we are just rotating the second tourmaline crystal. The first tourmaline crystal, it is remained unchanged, right? It is remained unchanged or constant. This is polarized light. Now I am rotating this P2. While rotating the P2, slowly the intensity of light starts decreasing. So here now I am rotating the second tourmaline crystal. When I am rotating the second tourmaline crystal, the intensity of light starts decreasing. Okay. Now at one particular position, the plane of tourmaline crystal becomes perpendicular to the plane of first tourmaline crystal in such a way. If this is the plane of first tourmaline crystal, the second tourmaline crystal's plane becomes perpendicular to the first tourmaline crystal plane. Now at that position, we will not observe any light. Means the second crystal is not transmitting any light, right? When I am rotating the second crystal, slowly the intensity of light starts decreasing, and when the plane of this P2 becomes perpendicular to the plane of P1 in such a way, no light is transmitted through P2, which clearly proves the transverse nature of light. So, which clearly proves the transverse nature of light. Now here, the axis or plane has become in such a way, and our vibrations are perpendicular to the direction of propagation of light. So these perpendicular vibrations cannot transmit through this plane now. So only we find darkness, means no light is passed through P2, which proves the vibration of particles are perpendicular to the direction of propagation of light, which proves the transverse nature of light. Now here the another thing is, now here the vibrations are perpendicular to the direction of propagation of light, we are saying, means they are vibrating only in one direction. They are vibrating only in one direction, which proves the property of one-sidedness of light. So this one-sidedness of light, we call it as polarization. So the light which acquires the property of one-sidedness, we call it as polarized light, and phenomena we call it as polarization, right? So now here what is happening? Generally, unpolarized light means it will spread in all directions and travel with different velocities in all direction. But here polarized light, it will travel only in one direction. It is having the property of one-sidedness. That light we call it as polarized light. So tourmaline crystal has that particular ability to convert unpolarized light into polarized light, right? So this is about the transverse nature of polarized light as well as the definition of polarized light. Now next let us move for the Brewster's Law. Brewster, or we can also call it as polarization by reflection. So Brewster want to prove the reflection laws for polarized light. So he did experiment on number of different surfaces and came to conclusion that first, let this be the glass, air, the normal drawn to the boundary separating two medias. This is incident light, unpolarized light. Now this is angle of incidence, angle between normal drawn and incident ray. This is unpolarized incident light. Incident light, right? As per light properties, partially it refracts, partially it reflects. Okay, this is a reflected light and this is refracted light. Angle of refraction, let it be R, angle between refracted ray and the normal drawn. Now Brewster started changing angle of incidence. When for the initial first angle of incidence, he finded that only partially the reflected light has converted into polarized light. Partially only, means some light is polarized, some light is unpolarized. Partially the reflected light has converted into polarized light. Now he started changing angle of incidence. He observed that at one particular angle of incidence, this reflected light completely converted into polarized light. At one angle of incidence, this reflected light has completely converted into polarized light. So that angle of incidence at which the reflected light completely converts into polarized light, we call it as angle of polarization, or we can also call it as Brewster's angle. Okay, the angle of incidence at which the reflected light is completely polarized, we call it as angle of polarization. Now it follows the reflection laws. I will be equal to P. P is angle of polarization, where the reflected light completely converted into polarized light, right? Now next, Brewster was successful in proving that the tangent value of angle of polarization is equal to the refractive index of a medium. This we call it as Brewster's law. The tangent value of angle of polarization is numerically equal to the refractive index of the medium. We call it as Brewster's law. Now tan P means nothing but we can write it as sin P by cos P, no? That is equal to mu. According to Snell's law, what is mu? Sin I by sin R, right? Now sin P by cos P is equal to, in place of I can substitute the angle of polarization, no? As per Brewster's law, Brewster's theory, I can substitute angle of polarization, because at that angle only, at one particular angle of incidence, which we call it as angle of polarization, the total reflected light has converted into polarized light. So I am substituting P, angle of polarization, in place of angle of incidence by sin R. Sin P strikes off. Sin R is equal to cos P. We can write cos P as sin 90 degrees minus P, or R is equal to 90 minus P, or R plus P equal to 90. R is angle of refraction, P is angle of reflection. So both are at right angles to each other, or are perpendicular to each other. So this is a Brewster's law. Okay. Now next, let us move for Malus law. Malus law, right? Now polarizer means that which polarizes unpolarized light into polarized light. Analyzer means which analyzes whether the incoming light is polarized light or not, right? Now let this be the polarizer axis, let this be the analyzer axis, angle between them is theta. Let A be the amplitude of polarized light, right? Now let us resolve this amplitude into two components along analyzer axis. One along analyzer axis A cos theta, other perpendicular to the analyzer axis A sin theta. Now when we start rotating the analyzer, what happens? Only parallel components are transmitted, because parallel components are along the analyzer axis. So if we rotate that also, they come out, but perpendicular components will not come out through the analyzer axis. Okay. So now here the total intensity of polarized light is only due to the parallel components. So the intensity means what? Nothing but equivalent to amplitude square. So now here the intensity of polarized light transmitted through analyzer. Let it be I theta. It is equal to what we will write? Intensity means amplitude square, no? A cos theta is coming out. So A cos theta whole square. So I theta equal to A square cos square theta, or I theta equal to, this is nothing but maximum intensity, cos square theta, or I theta proportional to cos square theta. So Malus law states that the intensity of polarized light transmitted through analyzer is directly proportional to square of cosine angle between polarizer axis and analyzer axis. The intensity of polarized light transmitted through analyzer axis is directly proportional to square of cosine angle between polarizer axis and analyzer axis. So this is about the Malus law. Thank you.